All right, guys, so this is the exam overview. Let's go ahead and see if we can take care of this really quick and upload it really fast. So this one, question number 1, it says find the period, amplitude, phase displacement, and sinusoidal axis location. So it's pretty straightforward. The period, well, this is a b here, so you can just do 2 pi divided by the b. If you look at it, you can put a 2 there and then make that an 8. So the period has to be 8. If you didn't like that, no big deal. You could have just done 2 pi divided by pi over 4 and keep change flip, 2 pi times 4 over pi, and you'll get your answer of 8. The phase displacement, we're using cosine, so the phase displacement is going to be 3. To the right if you want to be specific. The sinusoidal axis location, it's also called the midline. You can call that 2. And I'm surprised, oh, their amplitude we're missing. And then the amplitude is just simply 5. And there it is. That's fine. Sketch graph showing at least 2 complete cycles. So if I want to see 2 complete cycles, I'm going to start at the midline. So let's see. So here's 2, and then I'm going to go 5 above. So 5 above is 7. I'm going to say 7's right there. And then 5 below, so that'd be -3. And then here's the midline. Start with peak at 3, and it wants to see at least 2 complete cycles, guys. So since the period is 8, let's see, 8, 9, 10, 11. So I'm going to say 11's right here. Period, and then I'm going to go to another 8. I'm going to say 19 is right here. And there it is, at least 2 complete cycles, because I see 1 peak to 1 peak, that's 1 cycle, and then 1 peak to another peak, that's another cycle. In between your 3 and the 11, I have a min, so somewhere like right there. 4, 5, 6, 7. If you want to be specific, at 7 and at 15. And then in between your max and min, you have a point of inflection, point of inflection, point of inflection, point of inflection. And there it is, guys. Not perfect, but good enough. Find a particular equation for the circular function graph. Circular for the sinusoidal function graph. So let's see. That's a 1. That's a 7. So the period is 6. And then if I use cosine, the c is going to be 1 to the right. And then the midline appears to be 5. And then the amplitude from 5 to 7, that's 2. So amplitude is 2, and I think that's all I need. So the b value is 2 pi over 6, which is pi over 3. So here you go, y equals 2 cosine pi over 3 x minus 1, close, close, plus 5. And that's it, guys. Pretty straightforward. Go to the next one. So this peak is at 100, and I see a minimum at 900. That's 50% of a cycle, or 50% of a period, if you want to say that. So then I know, let's see, so the period from 900 to 100, or the difference between that, is 800. So the period is 1600. So that's how long it's going to take for me to go to another peak. So at 1700, I have another peak. Then from there, the amplitude, well, the midline, they make it pretty obvious here. They say it's -2.4. And then your amplitude is going to be, well, the high point is at 4.8. So 4.8 plus 2.4, what's that? 8, 4, 1, 4, 5, 6, 7. So 7.2. 8, 5, 6, 7. Yeah. Amplitude is 7.2. And your C is going to be 100 to the right. And I already found the midline. And okay, so I think we're ready, guys. Y equals, Amplitude is 7.2, cosine, and then the period is 600, so that means pi over 800. Because it's 2 pi over 1600, it reduces, right? And then x minus 100, close, close, and then minus 2.4. And there it is, guys. If you see any mistakes, let me know. Okay, on this one, it says, find a particular equation of the sinusoid. Okay, so let's do that first. I have a peak at 3 and another peak at 23. So the period is 20. And I got that from just taking the difference. Let's see where the low is. The low is negative 3. So the midline is going to be in between 7 and 3. So 7 minus 3 is 4. And 4 divided by 2 is 2. So the midline is at 2. I don't know why I did that there. And then the amplitude is the distance from 2 to 7. So that's going to be 5. And that should be the same from 2 to negative 3. And it is. So now all we need is midline, amplitude, period. Well, I guess with a B, right? 2 pi divided by 20, so it's going to be pi over 10. So the equation is y equals 5 cosine pi over 10, parenthesis x minus 3, close, close. I could have used 23 as well. It's the same thing. And then midline is at 2, so plus 2. So there it is. There's my equation. And then letter B says to find these values. It tells me to use a calculator, or I guess also with Desmos, since Desmos is a calculator, within the domain. So pretty much I'm going to find just those specific, so those 4 points. So for letter B, let's see, that's y equals 6. So I'm going to type this into Desmos, guys. Let me see if I can remember my equation here. I'm going to write it down on the side here. 5 cosine pi over 10 x minus 3, close, close, plus 2. And let's open up Desmos. Desmos. Graphing calculator. So here we go. Y equals, so I'm going to call it f of x. No, yeah, yes. F of x equals 5 cosine pi over 10. Open another parenthesis. X minus 3. Close, close, plus 2. And let me fix it within the domain. It was something like that. Because I remember there was 4 intersections. And then here I'm just going to type y equals 6. And here are my 4 intersections, guys. 0.952. I'm writing them here on the side, guys. 5.048. And then if I take this number and I add another 20, I should be over here. 25.048. And if I take the 0.952 and I add 20, because 20 is the period, you'll be right here in this one, 20.952. See, so none of this should be a surprise for you guys. So now I'm going to go back. We're having a lot of fun right now. We're going to say x equals 0.952. And then if you want to put them in order, 5.048. And then 20.952. And then 25.048. All right, and then letter C says find all x values algebraically. Show work for full credit. So here's what they want to see. Well, here's what I want to see. I'm going to write 5 cosine pi over 10 x minus 3, close, close, plus 2. All that shebang equals 6. And I'm just going to solve for x, guys. So subtract the 2. When you subtract the 2, that 6 turns to a 4. So 5 cosine pi over 10 x minus 3, close, close, equals 4. And then divide by 5. So when you divide both sides by 5, then you're going to get cosine pi over 10 x minus 3, close, close, equals 4/5. I'm going to come over here. And then to get rid of the cosine, you're going to do arc cosine, pi over 10, x minus 3 equals plus minus arc cosine of 4/5 plus 2 pi n. And then you're going to multiply by the reciprocal of pi over 10, so 10 over pi. So x minus 3 equals plus minus 10 over pi, arc cosine of 4/5, plus the pi's cancel out, and then 10 times 2 is 20, so 20n. And then just finally move the 3 to the other side. So x equals 3 plus minus 10 over pi, arc cosine 4/5 plus 20n. So here are my two solutions. The first one I'm going to do the plus. x1 equals. So 3 plus 10 over pi, arc cosine 4/5. So let me take out my calculator again. Yeah, that's fine. I can use this. So I'm going to write 3 plus arc cosine, where are you? 4/5. Oh, there's the 10 over pi in the front, huh? 10 over pi. And there it is, guys, 5.048. If you want to write more decimals, that's fine. 5.048 plus 20n. So I'm going to come back. 5.048 plus 20n. So you can see the 5.048 is right here on letter B. And if I add 20, you get the 25.048. So that one's good. And now I need my second equation. So instead of a plus, I'm going to do a minus. So I'm going to come back. And I'm just going to change that plus to a minus. So delete, put a minus. And there it is, guys, 0.951, or 952, really. So I come back. Oops, that's my editing software there, guys. So here we go. So I come back and I put 0.952 plus 20n. That 0.952 is right here. And if I add 20, there it is, 20.952. So I found them all, guys. We got them. You can stop right there because those are going to give you, or if you wanted to, you can just rewrite the 0.952, 5.048, 20.952, 25.048, and you're done. So we're going to do the same thing for number 5 here. All right, on this one, guys, I see a max at -7 and a min at 1. So then I know that I have another max at 9 because the distance between -7 and 1 is 8. Hold on, guys. I need a caffeine fix real quick. All right. So now that I know that, I'm going to go ahead and get my equation here. The period is 16. You can put an equal sign. Doesn't have to be a colons there. Let's see. The amplitude, I guess we should get our midline first. 4 plus a -2 is 2, and 2 divided by 2 is 1. So the midline is 1. And then the amplitude for the distance from 1 to 4 is 3. And that's also the distance from 1 to -2. And then the C, you can actually use the 9 or the -7. Heck, you can even use the 1 if you want to have a negative vertical dilation. I'm going to plug in a 7. So -7 to the left. And I have everything I need. So letter A is just going to be y equals, let's see, 3 cosine, and that's going to be, the period was 16, so it's going to be pi over 8 x plus 7, close, and then plus 1. And there it is. Hopefully I was able to fit everything, and it looks like I was. Letter B wants to know where these coordinates are right here. So there is a total of 5. So I'm going to go ahead and use Desmos for that. It says y equals 1.5. So let me write my equation down really quick because, you know, y equals 3 cosine pi over 8, x plus 7, close, plus 1. And here we go. So I'm going to clear all here. And y equals 3 cosine pi over 8. Pi over 8. Move, and then x plus 7. Close. Oh, that's not close. And then plus 1. And there it is. And then it was 1.5, I believe. Y equals 1.5. And they wanted, let's see, how many did I have? I think it was like right there, like that. Maybe it was that. I gotta look at the map. So let me look at it again. I start way over here. So those two, and then those two. So 5 total. So those two, and then the next one. Okay, so let's look at it. So here's -7. These two, those two, and then one more, and then that one. So here we go. Oh man, I moved it. So here we go, intersections. So write that number down, guys. So x equals -10.574. And then the next one is -3.426. And then if you add 16 to the -10, you'll be right here at 5.426. And if you add 16 to the -3, you'll be at the 12.574. And last but not least, if you add 16 to the 5.426, you'll be at the 21.426. All right, so let me write those numbers down, guys. So here are my solutions for letter B. Do I have enough room for letter C? I don't know if I have enough room for letter C, guys. Here's letter B. I'm going to write it in green. X equals a -10.574, comma, -3.426, comma, 5.426, comma, 12.574, comma, 21.426. All right, letter C, I'm going to write it right here as much as I can. So I'm going to write my equation. 3 cosine pi over 8 x plus 7, close, plus 1 equals 1.5. Oh, look, I think we're going to have perfect gradients. Oh, no, we're not. Because I'm going to be divided by 3. Minus 1, that's going to be a half. So 3 cosine pi over 8 x plus 7, close, equals 0.5. Or a half. Divide by 3. Cosine pi, I'm going to turn this into a half, guys. Cosine pi over 8 x plus 7, close, equals a half divided by 3 is 1/6, just 3 times 2. And then arc cosine, so pi over 8 x plus 7 equals plus minus arc cosine of 1/6 plus 2 pi n. And then multiply by the reciprocal. And I guess I can still write up here, right? So x plus 7 equals, so 8 over pi, arc cosine, that's an S there, of 1/6 plus 2 pi n. Oh, I didn't multiply the 2 pi by the reciprocal. So 2 pi times 8 over pi, the pi's cancel out and you're going to get 16n. And that 16 should be the period, and it works. And then finally move the 7. So -7 plus minus 8 over pi, arc cosine of 1/6 plus 16n. All right, so let's see what two solutions I get. -7 plus 8 over pi, arc cosine 1/6. So I'm going to come back, and let's see, -7 plus 8 over pi, arc cosine, 8 over pi, arc cosine of 1/6. So -3.426. Oops, again I quoted that. -3.426. -3.426 plus 16n. And notice that -3.426 is right there. And then my second equation, instead of a plus, I'm going to do a minus, guys. So I'm going to get rid of that plus. I'm going to put a minus. -10.574. So come back. -10.574 plus 16n. And notice here's the -10.574. So if I take the negative 10.574 and I add 16, I'm going to be at the 5.426. If I take the 5.426 and I add another 16, I'll be at the 21.426. If I take the negative 3.426 and I add 16 to it, guys, I'll be at 12.574. There you go. I found them all, guys. Yay. All right. Going back on this one says solve algebraically. 2 sine 2x minus pi over 3 equals square root of 3. And this is a perfect radian, guys, so you want to use perfect radians on this one. Divide by 2. So you're going to have sine 2x minus pi over 3 equals square root of 3 over 2. I already divided by 2, guys. And then on the unit circle, sine is the square root of 3 over 2 in quadrant 1 and in quadrant 2. Remember that sine is the y value. Trying to give you that visual there. So where does that happen? I'm going to go ahead and do the inverse already, guys. 2x minus pi over 3 equals arc sine of square root of 3 over 2 plus 2 pi n. So from here, I'm going to get my two equations. Equation number 1, where's arc sine square root of 3 over 2? Well, the first one's at pi over 3. So 2x, I'm going to put a subscript of 1 minus pi over 3 equals pi over 3 plus 2 pi n. And then my second equation, 2x of 2 minus pi over 3 equals, and that happens in quadrant 2, that's going to be a 2 pi over 3. So there it is. There are my two equations. I'm going to take equation number 1 first, guys. I'm going to go ahead and add pi over 3. So let's see, 2x1 equals pi over 3 plus pi over 3. That's a 2 pi over 3 plus 2 pi n. And then divide both sides by 2. So 2 divided by 2, the 2's cancel out, so you just get pi over 3 plus pi n. All right, now let's take the second equation here. I'm going to add pi over 3 again. 2x2 equals 2 pi over 3 plus pi over 3. That's a pi plus 2 pi n. And I'm going to divide everything by 2. So x of 2 equals pi over 2 plus pi n. I don't see any mistakes. So now I want all my solutions between 0 and pi. So my only solutions between 0 and pi are pi over 3, so 1/3 of pi, and pi over 2. If I had pi, guys, I'm outside the domain. So there it is. On this one here, you're gonna have to FOIL or factor out. FOIL, sorry guys. So this is similar to your algebra days when you had 2x squared minus x minus 1 equals 0. So all you're doing is factoring. So when you guys were in algebra, you would just do this, right? The only way to get a 2x squared is 2x times x. The only way to get a 1 is a 1 times 1. You want to add up to a negative 1. So that means you want the larger number to be negative. So 2x times a 1, that has to be a negative. This one has to be a positive. And it's the same thing, guys. If these are your factors for the 2x squared minus x minus 1, then those are your factors for the 2 cosine squared minus cosine minus 1. So it's going to look like this. 2 cosine x plus 1, cosine x minus 1. See? And then we just solve. So where does cosine x equal 1? Well, cosine x equals 1 at 0 and at 2 pi. So those are going to be part of my solutions. And then we do this one. Where does 2 cosine x equals a negative 1? Well, I divide by 2. Cosine x equals a negative half. On the unit circle, your negative half, let's see, up in quadrant 2 and down in quadrant 3. So those two coordinates are, or those two radians are 2 pi over 3 and 4 pi over 3. So my solutions in order are 0. Let's see, then which one comes first? 2 pi over 3. That's a 3 there, guys. 4 pi over 3. And then finally 2 pi. If you don't want to put them in order, that's fine. I'll take them out of order. I don't see any mistakes. Let me know if I went too fast there. And then finally, the last question here. Let's see what it says. You finally obtain your driver's license. Hey, congratulations. As you stop your truck at a traffic, well, your car. It doesn't have to be a truck, right? Your car at a traffic light, a little pebble becomes wedged between the tire threads. Oh, okay. When you start moving again, the distance between the little pebble and the pavement varies sinusoidally with the distance you have gone. Okay, it makes sense. The period is the circumference of the tire. Yeah, that makes sense, guys, because the tire, if the pebble is stuck right here, it travels the entire distance of that tire up and down over and over again. And I tell you, they're nice. We're nice. Assume that the diameter of the tire is 24 inches. So the diameter of the tire is 24 inches. That's going to be, my circumference is 24 pi. Sketch the graph of the sinusoidal function show at minimum 2 cycles. Okay, so the smallest you'll ever be is at 0, because that's ground level. And that happens initially when you step on it. And then the biggest you'll ever be, well, this tire has a diameter of 24 inches. So the biggest you'll ever be is 24. And this is in inches. And so initially I'm at 0, right? Because your tire's just hitting the pebble. And you do a revolution every 24 pi, because that's how long it takes to go all around. So the pebble's going all around. So every 24 pi, you're back in the same location at 0. So 24 pi, I'm going to say it's 24 pi, then I'm going to go 48 pi. And so on and so forth, guys. Sorry, guys, I needed a coffee break really quick. It wanted at least another cycle, right? So I'm going to do another one, because it says to show at least 2 cycles. So 72 pi. So there it is. So the midline is at 12. So that's the middle between 0 and 24. All right, let's see. So in the middle between 0 and 24, I better have a max. Because look, this is a min. Oh, I better put it in blue. A min, and then in the middle, so at 12 pi, I have a max. In the middle here, another max. Middle there, another max. If you want to know where the max is at, that's 36 pi. And that's 60 pi. And so here we go. And then in between the 12 and 24, you have a point of inflection. They don't have to be perfect, guys. This is a pebble, by the way. It's going up and down on the tire. It's going up 24 inches and it's coming down 24. And it's traveling around the tire over and over again. So there it is. Find a particular equation of this function. All right, let's find that equation. We said that the period was 24 pi. We know one of the peak is at 12 pi. If you wanted to use a point of inflection, you could, because we actually could calculate that. But we're still going to stick with cosine. If you want to use the negative dilation, we can. So the period is 24 pi. So then that means from that we can get the b. 2 pi divided by 24 pi. That's going to be 1 over 12. The midline, or the sinusoidal axis, is going to be at 12. The amplitude is going to be at 12. And my phase shift, if I want to use cosine, I'm going to say that that's 12 pi. 12, 12, 12. 12 everywhere. Y equals 12 cosine 112 x minus 12 pi, close, plus 12. 12 all over the place, guys. Love it. All right. What is the pebble's distance from the pavement when you have gone 15 inches? So when you have traveled 15 inches, they want to know how far are you off the pavement, which is this blue curve. So let's go ahead and put this on Desmos, and we're going to figure it out right now. Or you know what? You can just plug in 15 inches into that x value. But I'm going to use Desmos anyways. So 12, I think I can remember all the 12s, right? So let's see. I'm going to write f of x, because I might have to use a table maybe. Equals 12 cosine 1 divided by 12. Move to the right, open parenthesis, x minus 12 pi close, close, plus 12. So there it is. At least 2 cycles. Perfect. All right, and oh man. And here we go. I'm gonna make a table. You don't have to, guys. You can just plug in the x directly immediately. And close f of x. And I'm just gonna type in 15. You could have typed in 15 directly. 8.216. I'll push enter. So there it is. So there you are, guys. That's how far off the ground. Remember, this pebble is on the tire, and it's rotating. The tire's rotating, and when it's way up here at 24 inches, that's when the pebble is at the highest point of the tire, at the very top of the tire. And then as the pebble's going down, that means that the tire is rotating, and then bam, it hits the ground again. So it's 8.21 or 22 inches off the ground. I think if I were in inches here. Were we in inches? 24 inches, yeah. Let's answer the question. What are the little pebbles' distance from the pavement when you have gone 15 inches? When the tire has traveled 15 inches since the pebble got stuck, comma, the pebble is, and I already forgot, 8.22 inches. Is 8.22 inches. Oh, 3 digits, right? 3 digits. 8.216. 8.216. 8.216 inches. You could also use the single quotes for inches. Off the ground. There we go. We answered that question. What are the first 2 distances you have gone when the pebble is 10 inches from the pavement? Okay, now I want to know the first 2 values when I am 10 inches from the pavement. What are the first 2 distances you have gone when the pebble? Okay, so one of them is on the way up, and the other one is on the way down. So let's figure that out, guys. I come over here. I'm going to go to y3 or the third box here. And I'm just going to equal y equals 10. And there it is. This is my first value. So at this moment, I'm on the way up at 16.84, and we can get more digits on that. Give me more digits. And then the next one happens at, hold on guys, this is being sensitive, at 58.558. So this one's on the way up, and this one's on the way down. So let me see if I can get more digits on this. Maybe it's 16.840, right? That's fine. All right. So first, like since you did it all with the calculator, guys, at least tell me what you're doing. So at least show this. Go 10 equals 12 cosine. Because that's really what we're doing, guys. 112 x minus 12 pi plus 12. That's really what you're doing. And you're finding the first 2 instances, which is the same thing as like find the first 5 positive values that we tell you on other things, or the first 2 positive values. So the first value happens at, and I already forgot the value, 16.84. And then the next value happens at 58.558. And I believe those are the first ones. Yep. 58.558. And remember what you're doing, guys. It says, what are the first two distances you have gone when the pebble is 10 inches from the pavement? So I'm going to put, let's see, the tire, since the pebble getting stuck, which I guess is understood, so we don't have to put that. The tire has traveled 16.84 inches when the pebble, that's not plural, reaches 10 inches off the pavement. Going up. And then semicolon, and then I'll put the tire has traveled 58.558 inches, because remember, it's just going in circles, right? The child has traveled 58.558 inches when the pebble reaches 10 inches off the ground, going down. All right, cool. Let me know if all that made sense, guys. If it didn't, show up to tutoring. I'll be in tutoring today at 4 o'clock, and then again, well, I guess by Wednesday it'll be too late. But I'll be in tutoring today at 4 o'clock from 4 to 5:30, and then at 5:30 I have an engagement where we have the Mu Alpha Theta induction ceremony. But I'll be in tutoring today, guys, if you guys need any help. All right, guys. Talk to you guys later. Bye-bye.